Welcome back. So we've talked about earthquakes, how they occur generally, where they occur, the faults that create these earthquakes, and from whence the seismic waves emanate from. And now we're going to use that kind of knowledge of seismic waves as well as some additional details to measure earthquakes. So let's jump into this. So there's a couple ways to measure earthquakes. The first being the magnitude. This is a measurement of how much energy is released during the earthquake. The following measurement scale, you may have heard of it before, not necessarily know what it is, but it's called the Richter magnitude scale. And again, it goes to measure the amount of energy released in an earthquake. So what it does, it uses seismic wave reading stations kind of around to kind of measure distances based on seismic waves that these measurement devices are away from the epicenter to kind of zero in on the location, as well as to measure the maximum amount of ground displacement, typically due to the S wave, the secondary wave, which, as mentioned in a previous video, much more movement, much more destruction once that secondary S wave comes, which is the second. P primary, fastest, that gets to you first. S wave, secondary, that gets to you second. The Richter scale is logarithmic. Hold on, it's going to get a little mathy. Which means the increase from one integer to the next integer is approximately a measurement of 10 times greater ground movement and 32 times more energy released. So let me give you an example. So, this is what they usually say on the news. A Richter magnitude 5.0 earthquake shook San Francisco today. So this is that Richter magnitude scale. For an example, so the difference between a Richter magnitude 7 and a Richter magnitude 8 earthquake is that there's 10 times more ground movement from one to the next, 32 times more energy released. Well, let's see how that plays out with a couple of steps and what that means. Let me move me real quick. So instead of going from a 7 to an 8, let's jump from a 7 all the way to a 9. How much more energy is released? So it's multiplicative. You're not adding 10 plus 10, so it's 20 times more ground movement. No, logarithmic means kind of multiplicative, so it's 10 times 10. So the difference between a 7 and an 8 versus a 7 and a 9 is there's 100 times more movement. And then as far as energy is concerned, 32 times 32, over 1,000 times more energy is released in a 9 than in a 7. So each step you go on the scale is not additive, it's multiplicative. So they get, as you get higher and higher and higher on the scale from 0 on up, every step is a lot more movement, a lot more energy. Looking as far as the past 10 years are concerned, and at least up to what we have right now in 2021, you can see on average there's about one, maybe two Richter magnitude 8.0 or above earthquakes. When you get into earthquakes that big, they happen once, maybe twice a year on average. But you can see that the lower the scale, the much more common they are. When we're looking in the 4 range, we're in the tens of thousands. In the 5 range, 1 to 2,000. 6 range, 100 or 200, somewhere in there. 7 range, 10 or 20. 8 or above, again, those are kind of rare, thankfully. But look what's going on in 2021. So far, we've already had 3 earthquakes around the world at an 8.0 or above. So, pretty destructive year so far. And already 10,000 at this point of when this video was made. On average, again, so these are just kind of averages. 8 or above, on average, 1 or around 1 on average a year. And you can kind of see the averages. Minor earthquakes, we get a lot of them. Very minor earthquakes in the millions, approximately 150 per hour. When they're that low on the scale, sometimes they're not even felt by humans. They can be detected by machinery and measurement devices, but not felt, not really causing destruction. So the thing is, though, with the Richter magnitude scale, it's not really helpful to non-scientists. They say the number on the news, they might say it on a movie, watch out, it's an 8.0. Okay, what does that mean? Because this is a measurement of energy, ground movement, it's mathematically based, it's graphically based. What you're basing this measurement on are seismic waves. So measurements of P waves and S waves. So again, it's not very meaningful to the non-scientist. We use a seismograph to measure the magnitude. That's the thing. You've probably seen them on the movies that starts to scribble on the piece of paper when the earthquake is happening. Yeah, again, and it's those scribbles that we actually take, the scribbles, called a seismogram. That's the printout that we use to take some measurements of, and we'll do that in lab, in some activities in lab. So back in the day, it used to be just a big roll of paper and literally like a little pen or pencil to scribble. Nowadays, it's more so all computer digitally based. But again, it's kind of meaningless to the non-scientist because, all right, so Richter 8.0 means this much energy was released and the ground moved that much. Well, what does that mean? Did people die? Did buildings fall down? So it's just a quantifiable number of energy released and movement. It doesn't really determine how much destruction was going on. So again, looking at 8 or above, they're very rare. In fact, there's only been 5 earthquakes that have ever been recorded in recorded history at a 9 or above. Only 5 ever. Now, that's recorded because we haven't had the measurement devices to do so. Now that we do, again, so only the past 100 or 200 years, but in that time, only 5 have been recorded at a 9 or above. So if you look at some of the references to what an earthquake is versus other things that we know, for instance, the world's largest nuclear bomb that ever went off would only be an 8.0 on the Richter scale. So again, when you're getting into 9, you're talking about a lot of energy, a lot of destruction. The average tornado, is equivalent to just under between a 4 and a 5. So earthquakes, there's a lot of energy release. They are massive and massively destructive. So the top 5 earthquakes in recorded history that have been measured, again, there's only been 5 at a 9.0 or above. So down in Chile was the highest recorded in 1960. That was a 9.5. Second place, Alaska in 64, a 9.2. Recently, 2004 in Indonesia, 9.2. Massive earthquake, tsunami followed. Same thing in 2011 in Japan, 9.1. Massive earthquake, massive tsunami. And then on the Kamchatka peninsula of Russia. So these are the biggest magnitude earthquakes ever recorded. You notice where they all are? They're all surrounding the Pacific Ocean. So the area around the Pacific Ocean, a lot of boundaries, typically a lot of convergent boundaries in these areas. Convergent boundary, same as you go down here. So this is a very tectonically active area all around the Pacific Ocean. But besides magnitude, there's other deadly effects. As mentioned, a lot of these big earthquakes also cause some secondary effects like tsunamis. So you have to kind of, consider that when talking about earthquakes. You also have to think about some other things. The architecture, population. Did these earthquakes even occur where people are? If these earthquakes occurred in the middle of nowhere, then no big deal. All right. The geologic conditions. What kind of rocks are underfoot? How deep was the earthquake? Was it closer to the surface where a lot of that energy is going to reach the surface? Or is it further down where that energy kind of dissipates away? When you're talking about just a magnitude, 9.0, it doesn't explain any of that stuff. It's just a measurement of how much energy was released. Okay, there was a 9.5. That's the highest ever recorded earthquake in Chile. Okay, what does that mean? Were there people around? Did buildings fall? Did people die? Was there a tsunami? What's going on there? It's kind of meaningless to the non-scientists. So there's a different type of measurement device or measurement method, and that's intensity. Intensity measures the maximum intensity of shaking at a location. It's what you feel and the destruction done. Because shaking will vary from place to place in a given earthquake, the further from an epicenter, the less shaking you would feel. So does the intensity. So with a magnitude scale, if it's a 9.0 earthquake, that's just what we call it for the earthquake. But when we're measuring intensity, we can go city by city and, this city felt it worse, this city didn't feel so worse. So it depends on all of those things. Are people there? What kind of architecture and buildings are there? What kind of rock is underfoot? Etc., etc., etc. So we use a scale called the Modified Mercalli Intensity Scale to measure intensity. And it's based on descriptions, again, of what people feel, what they see, and the damage that has occurred. And the scale, again, does differ. So with a Richter magnitude scale, we just say it's one number for the entire earthquake. With this, we can assign different values depending on different locations. And again, it's based on what people feel, what they see happening, the destruction done. And it's measured using Roman numerals from 1 to 12. And this is definitely more meaningful to the non-scientist because you just describe what you feel. So, for instance, if you were driving around, or if you were just sitting in your car and you felt your vehicle kind of shaking slightly, well, then that would be a 3 on the intensity, modified Mercalli intensity scale. You're sitting there, you're like, wait, what's going on here? So it's based on what you feel and also kind of what you see, kind of what kind of damage was done. For instance, if you're in your home and some of your dishes fall out of the cabinet and break, or some of your windows break, maybe something that's unstable like a big bookcase falls over, well, maybe that's a 5 on the intensity scale. It's a little bit more intense than if you just felt it sitting in your car. So it's just a way to, again, describe what you feel, what you see happening, and then that way you can assign some sort of measurement to it. Oops, excuse me. And again, the further you get away from the epicenter of the earthquake, typically the lower values in intensity you get. So if you want to figure out the epicenter using the modified Mercalli intensity scale, well, where was the most stuff felt or damage occurred? And as you get further and further out, that value can decrease. But again, much more meaningful, Mercalli intensity measurements are much more meaningful to the non-scientists because anyone can say, oh man, I felt this, I felt that, I saw this happen, I saw that happen. All right, so we're going to pause there. So that's a couple of ways of how we measure earthquakes, and we'll look at those in lab. So we'll pause there, and when we come back, we'll talk about the impacts on society from earthquakes. All right, so I guess the section didn't have 2 videos, just the one. All right, so I'll see you back here in just a minute.